Assalamualaikum and welcome to the part 4 for chapter 6 gravimetry analysis. So in this video I will explain about the procedure for digestion. So what is the digestion? So digestion is a process which is the precipitate. We keep the precipitate within the model liquor or solution from which it precipitate for a certain period of time to encourage densification of nuclei. During digestion, sometimes the small particle dissolve back into the solution and it will produce the large particle. And this process is called the Oswald ripening. This process helps produce the large particle that are more easily filtered from solution. So Oswald ripening improves the purity and crystallinity of the precipitate because the precipitate of the small particle which is hard to be filtered. So how to collect this particle? So by using Oswald ripening, this particle will be dissolved back into the solution and then it will produce another precipitate with a size bigger than before. So digestion, small particles are not retained by the ordinary filter. So that's the problem. So if we can collect that precipitate, so the result is not very accurate. So the digestion process occur to handle this problem. So digestion improves the purity and filterability of the precipitate. Digestion is usually done at elevated temperature to speed the process of agglomeration and coagulation. The digestion process is a phenomenon when a small precipitate, which is the particle below than 1 micrometer, which is present in the solution, which is precipitate, is allowed to grow from a form of a large particle or a large crystal when heated. A very small particle with a large specific surface area have a high surface energy and high solubility compared to the large colloid particle between 1 micrometer to 100 micrometer. So the small particle tend to dissolve and reprecipitate. So that is the digestion. When the small particle dissolve and reprecipitate, so the precipitate produced is bigger. Okay, so the small particles are coagulate or agglomerate using a coagulant to give a filterable amorphous mass that will be settled out of the solution. And the small particle can be often coagulated by heating, stirring, and adding electrolyte. Next is the peptidation. So peptidation is a problem. Peptidation is the process by which a coagulate colloid revert to its original dispersed state. So when a coagulate colloid is washed, some of them is leached from the dispersion medium in contact with the solid particle. So how to overcome this problem? So we wash with a solution containing an electrolyte that volatilize when the precipitate is dry or ignite. For the example, the silver chloride is washed by using a nitric acid in determination of silver chloride. Next is the contaminant of precipitate. Co-precipitation is a process in which normally solute compound or constituent are carried out from the solution by precipitate. It causes the precipitate to be contaminated. And there are 4 types of co-precipitation. We start with occlusion and inclusion. Next is the surface absorption. Next is the isomorphous replacement. And the last one is the post-precipitation. So co-precipitation of other ion also occur during co-precipitation by the body of the precipitate and also at the surface of the precipitate. So there are 2 types. There are 2 ways how co-precipitation happen, by the body and the surface of precipitate. So by the body of the precipitate, another ion present during a precipitate may be incorporated into the crystal, and then the precipitate particle will be grow with this ion that we don't need at the end or for the precipitate. And for co-precipitate at the surface, the impurities is found on the surface of the precipitate, and it occurs especially with gelatinous precipitate. So gelatinous is the precipitate, the type of precipitate like a gel precipitate, a jelly precipitate. So that is the gelatinous precipitate. So this type of jelly precipitate sometimes will absorb the impurities at the surface of the precipitate. Next is the occlusion and inclusion. So occlusion is the trapping of impurities within the crystal, and for inclusion is trapping of impurities within the crystal. Okay, so example for occlusion is water, for example, may be trapped in the pocket when silver nitrate crystal are formed. And for inclusion, the impurities is trapping in the crystallite, for example, potassium in ammonia, okay, in NH4 Mg PO4. So occlusion, for example, is water, which is trapped inside the crystal, and for inclusion is the impurities is trapped with the crystallite, okay, with the ion. So that's the difference between occlusion and inclusion. So occlusion and inclusion impurities are difficult to remove. Okay, digestion may be had, but this is not completely effective. So purification by dissolving or precipitating may be helpful. Next is the surface absorption. So when the high relative supersaturation will also increase the nucleation. So when the nucleation is increased, many small crystals form, and when the many crystals form, so small crystal produce the more surface area. So when the particle is got the more surface area, so what happened? So there is more surface absorption. So when there is more surface absorption, that means there are more impurities can be formed. So more or less surface area in the precipitate lead to more surface absorption and more impurities. So that's why we need the precipitate with a low surface area. Low surface area means the particle is bigger. Okay, the particle is bigger, should be a low surface area compared to small particle. So the small particle have the high surface area. So this surface absorption problem should be reduced, can be reduced by proper precipitation technique, digestion and washing. This is the example. So you can imagine the crystal. Okay, you can imagine the crystal, the large crystal. The large crystal has 4 surface area. Okay, and if you break the piece into 2 pieces, so what happened? The crystal becomes small and the surface area is increased. So supersaturation increase, nucleation occur, precipitate will become small crystal and convert into colloidal form. And when colloidal form, which is the small particle, it will also increase the surface area. If the surface area is increased, so the chance to bind more impurities is increased. Next is the post-precipitation. When the precipitate is allowed to stand in contact with mother liquor, a second substance also slowly forms a precipitate with a precipitating reagent. So in this case, we need to get a precipitate A. So sometimes when you allow the precipitate, when you allow the analyte with the solution with a mother liquor for a long time, what happens? Another precipitate will be formed. So for example, when calcium oxalate is precipitate in the presence of magnesium ion, the magnesium oxalate does not form immediately precipitate because it tends to form supersaturated solution. Next example, copper sulfide will precipitate in acid solution in the presence of zinc ion, but eventually zinc sulfide also will precipitate. So that is the problem. Next is the isomorphous replacement. Isomorphous replacement is the mixed crystal formation. Two products are isomers, that means the same formula and the same types of crystal, a similar geometrical form and the same lattice dimension. So when this situation happens, sometimes, for example, we need the sodium chloride precipitate. Sodium chloride in the type of crystal is sodium and chloride. So sometimes another ion can react as sodium. Okay, why another ion can become as sodium? Because of the isomorphous, which means the similar geometrical form or the same lattice dimension. So one ion can replace another ion in crystal easily. So the product is not 100% pure. Okay, so example, in the precipitation of magnesium Mg2 positive as magnesium ammonium phosphate, potassium have nearly same ionic size as NH4 positive and can replace it to form magnesium potassium phosphate. So there are what we call different two situation. We need to produce A, but sometimes we can get 100% A because of the isomorphous replacement. Next is the mixed crystal formation, a type of co-precipitation in which the contaminant ion replaces an ion in the lattice of the crystal. So it may occur both in colloidal and crystalline precipitate. Another one is the mechanical entrapment. So mechanical entrapment occur when the crystal lies so close together during growth. So what happens? So when the particle is growth, sometimes the several crystal will trap a portion. Okay, sometimes the crystal will be trapped in the tiny pocket of the crystal. So that's will be impurities that is very hard to be adjust. So the method to prevent and eliminate co-precipitate. So for example, co-precipitate for surface absorption. So how to minimize and how to eliminate by using the digestion process, by washing with a solution contain a volatile electrolyte, and also by doing the re-precipitation. So by using this method, we can minimize and we can eliminate the co-precipitation by surface absorption. And for occlusion and mechanical entrapment, how to minimize and eliminate? So by using the digestion process, by use the dilute solution, and also the reagent is added by the slow addition of reagent. So that's all. Thank you.